So let's continue with the exam 2 review of calculus 2 part 2. So question number 11, we determine whether the sequence converges or diverges. If it converges, find the limit. So we have the sequence an equals to 4n squared minus 3n divided by 2n squared plus 1. So we find the limit as n approaches infinity of 4n squared minus 3n divided by 2n squared plus 1. And because we are approaching the right-hand side infinity, so we need to look at the end behavior of this function. So that means that it only depends on the highest powers of x in the numerator and the highest power of n in the denominator, so not x. So we can cancel the n's and we'll be having this as 4/2. So which simplifies to 2. So the limit equals to L. So this function converges, this sequence converges. That's the second one. So limit as n tends to infinity of this function, or this sequence, sorry. So we first of all multiply here by its conjugate. We can just say here divide by 1. And then we observe that in the numerator, it's of the form a, the minus, this is b, and this is a plus b. So a minus b and a plus b will just be the same as finding limit as n approaches infinity, a squared minus b squared divided by 1 times a plus b. So we can expand a squared. So we have the limit as n approaches infinity of the root of n plus 2, which is my a squared, minus the root of n squared. Then we divide by the root of n plus 2 plus root of n. So we get limit n approaches infinity. Square root of n plus 2 squared is n plus 2, minus square root of n squared is n, divide by square root of n plus 2 plus square root of n. So continuous simplification, we have limit as n approaches infinity of 2 in the numerator divided by the root of n plus 2 plus root of n. And then as n approaches infinity, the root of n plus 2 will become big plus another big number. Then we take 2 divided by a very big number, that becomes 2 divided by a very big number goes to 0. So then again, this one converges. So that sequence again converges. So we go to the sequence, the third question. So we find limit as n grows to infinity, then n to the power of 4 divided by n cubed minus 2n. So again, we find the n behavior of this function. So we only depend on the highest powers of n. So it's n power 4 in the numerator divided by n cubed. So this, if we simplify further, we get this limit as n approaches infinity of n, and that diverges because the limit does not exist. So the limit does not exist as n approaches infinity, so it diverges. The fourth one. So limit as n approaches infinity of cosine, I write n over n plus 1, then multiply by pi, should be the same. Then we find the limit, and because this is a continuous function, so we can find this arrangement, same as cosine. Then we find the limit as n approaches infinity of n over n plus 1. Let me write pi here. And we observe again, whatever is inside the cosine can still be written as limit as n approaches infinity. So the behavior will only depend with highest power of n, that's n over n, pi, and this is n over n, that's 1. So we have cosine of limit as n approaches infinity of 1 times pi, which is just pi. So getting an answer as cosine of pi, which is equals to minus 1. And that again converges. So that sequence converges. Let's go to question number 12, part 1. I'll change the color. So I have determined whether the series converges or diverges. If it converges, find the sum. So we will try to simplify this one. And we have sum as n starts from 3 to infinity. I can factor out 5 to get minus 1 over 3 raised to the power of n minus 1, which is again can be written as 5. The sum n starts from 3 up to infinity. I can use the rules of indices to write this one as minus 1 over 3 to the power of n multiplied by minus 1 over 3 to the power of minus 1. I can factor out the first part, the part minus 1 over 3 power minus 1. But if I was to flip using the rules of indices, I can have 5 times minus 1 over 3 to the power of minus 1 out of the summation sign, because those doesn't depend on n. N equals to 3 all the way to infinity minus a third to the power of n. So we observe that this part becomes 5 times. To drop the minus, I will flip the whatever is inside the parentheses to get times minus 3. And then that's when the power becomes 1. Then I have the sum as n starts from 3 up to infinity of minus 1 over 3 to the power of n. So this is minus 15. And this becomes the sum. Now, n equals to 1, n equals to 3. So if we want to have this sum, n equals to, we have n equals to 3. So we can write this as 3. If we subtract 2 there, so get n starting from 1 to infinity, we have minus a third, and that means we have n plus 2. So the space is small, but I have minus 15. The sum, n starts now from 1 to infinity minus a third, and I'll have power n times another minus a third, this to the power of 2. So let's use the space on this side. So we have minus 15, this sum, n equals to 1 to infinity. So I have minus a third to the power of n, and then multiply by minus 1 over 9, which can be factored out to get minus 15 over 9, and this sum, n equals to 1 to infinity minus a third to the power of n. So if, and that will give you minus 15 over 9. Whatever is inside, it's our ratio. And if the ratio, so our R equals to minus 1 over 3. So if the absolute value of R equals to is less than 1, which is equals to a third, and this one is less than 1, this means that this thing converges. So we have the sum n equals to 1 to infinity minus a third to the power of n. So to find the sum, we should have these are getting to the form, whatever is inside to be in the form of sum as n starts from 1 to infinity, a r n minus 1. So that means this is the formula for the sum. Let me write sum with infinity. So that means I can write, I can move one of minus a third inside. To be the form of sum as n starts from 1 to infinity, and then I will have minus a third to the power of n, and then I multiply by a third to the power of minus 1, which will become, this is like now a 3, so that means I'll be multiplying. So this is now my sum. I'm writing sum with infinity. So let me use this space here. So that means my sum with infinity, because I'm putting a 3 inside, so I'll be having minus 15 outside, and then I'll be dividing by 3 because one of the 3 has gone inside, and then I'll have the sum as n starts from 1 to infinity, then minus a third, and then I'll have my power here, n minus 1. So I have brought in 1 over 3 inside, or I just brought it in 3 inside, and I got this. So you have the answer as minus 15 over 3. And then the sum, the first term, A is 1. So you have 1 over 1 minus the common ratio, minus another, minus, we get a 1 plus a third. So this will become minus 15 over 3, which is 5, multiplied by this is 1, and then 4 over 3. So 1 in the numerator, 4 over this, so that's 3 over 4. So you get answer as minus 15 over 4. So let's go to the second one. Don't I miss that space? The second one, we can split it into two. So to have the sum, n starts from 1 to infinity, 1 over n plus 1, then plus this sum, 5 over 3, n equals to 1 to infinity. And the first one here is a telescopic sum, or telescopic series. And this is geometric. Series. So for the telescoping, we start by decomposing it into partial fractions. So we can have 1 over n plus 1 is equals to a over n plus b, because they are linear factors, n plus 1. So this we multiply by everywhere by n here, so we can multiply here by n plus 1. So we multiply everywhere here by n plus 1, here by n plus 1. So this will cancel to get 1 equals to a n plus 1 plus b by n. And then because we want to find the undetermined coefficients a and b, so to do that, we do a wise choice of n. So we choose n equals to 0. We'll be eliminating b, and we have 1 equals to a, or a equals to 1. If we choose n equals to minus 1, we will eliminate a, and we have 1 equals to minus b. So b equals to minus 1. That means that the first part of this series, n equals to 1 to infinity, can be written as a is 1 over n, and b now is minus. We'll be having minus 1 over n plus 1. So and let me call this one as n and find the limit, because that's that will be the sum. So if you have to find s of 1, you get 1 over 1, that's 1 minus a half. If we find s of 2, if we continue, the second part, it's like we continue of adding, so we have 1 over 2 minus 1 over 3. So the second part should be adding this part. The other one, the third one, will be 1 over 3 minus 1 over 4. So if I write s with a capital 3, meaning sum of all of them, is I'm having 1 minus a half plus a half minus a third plus a third minus a quarter. Those are 3 of them. So we have, in that case, s, the sum of all of them. Let me write, I'm writing as s with that infinity should be 1 minus a half added to the second one, a half minus a third, added to the other one, that one, a third minus a quarter. So the last one will be 1 over n minus 1 over n plus 1. And you find that the terms cancel each other, and you'll be left with 1 minus 1 over n plus 1. So to find the sum, we find the limit. So s becomes the limit as n grows of 1 minus 1 over n plus 1, which is just equals to 1. So for the first part, for the telescoping sum, the answer equals to 1. For the geometric, we have the summation as n starts from 1 to infinity. of 5 divided by 3 to the power of n. So we can factor out 5 and we having sum as n starts from 1 to infinity of 1 over 3 to the power of n. So the fact that this one is in that form, n equals to 1 to infinity, we have that the ratio r equals to 1 over 3. And we can find that a equals to 1. So again, this one converges. And the sum will be equals to 5 multiplied by a over 1 minus r. So this becomes 5 multiplied by, the first one is 1 minus r, and r is a third. So you have 5 multiplied by 1 minus a third is 2 thirds. So we have 3 over 2. That's 15 over 2. And then we add. So we have the first one gave you 1 plus 15 over 2. 8.5. And so having ARN minus 1. So let's check. This is n. So if I was to move 1 over 3 out, yeah, so we need to have in the form of the sum, n starts from 1 to infinity, ARN minus 1. So to have an Rn minus 1, let me clarify that part. For me to use that formula of a over 1 minus r, I need to have ARN minus 1. So that will mean that if I'm having 1 over 3 here, if I should be dividing, let me create more space for that matter. Let me erase this. So this can be 5 sum, n starts from 1 to infinity, 1 over 3 to the power of n. But because I want it to be in the form of sum, n starts from 1 to infinity, ARN minus 1. So whatever it's the R, it's 1 over 3. So if I factor out one of them, I'll have 5 with a 3. Then I'll have inside sum as n starts from 1 to infinity. Not factoring, but like multiplying. So if I multiply, so this is 5. If I multiply here by 3, it's the same as now, without changing the working, same as a third n multiplying here by 1 over 3. And that will be plus 1. So if I factor out 1 over 3, that means I'll be multiplying inside here by 3. So that's the calculation I wanted to do by 3 there. So I'll be having 5 over 3, in this case, 5 over 3. And the sum here, n starts from 1 to infinity, will now be a third. Then this one will be power n. Then if this is a power 1, so if I make it power minus 1, I'll be having 1 over 3 to the power of minus 1. And that's what is needed. So we'll be having 5 over 3. Sum as n starts from 1 to infinity, 1 over 3 to the power of n minus 1. And that's when you can use the the formula here. So getting the answer here is 5/3, then we multiply the answer for the sum. It's A divided by 1 minus R, which is equals to 5/3 multiplied by A. The A is the number in front, which is 1, divided by 1 minus the ratio, which is a third. And 1/1 minus a third, that's 1/2 thirds. So that is 1/3/2, which is equals to 5/3 multiplied by 3/2, which is 5/2. And then we add to the one which we had gotten before for the telescoping sum, this one. 1 plus 5/2. That should be the answer. So 3.5. For number 3, we use the divergence test. So that means that we take that term, that's n squared, and the term 5n squared plus 4. Then you find limit as n approaches infinity of n squared divided by 5n squared plus 4. And we only get concerned with the leading terms of these polynomials. So 5n squared over 5n squared. N squared we cancel to get 1/5. And since this one is not equals to 0, so this one diverges. For number 4, we can try to write this as the sum. N starts from 1 to infinity as 2 to the power of 2. Then n by the indices property. This is 3 to the power of 1 multiplied by 3 to the power of minus n. So we can factor out the numbers. That's 2 squared and 3. That's 12. No, don't factor out 2, sorry. So this becomes n equals to 1 to infinity. This is 4 to the power of n. We can factor out 3. Then you might have here 3 to the power of minus n. So this will become 3. The sum, n starts from 1 to infinity, 4 to the power of n, multiplied by 1/3. Now that one becomes to the power of n. So this becomes 3. Sum, n starts from 1 to infinity, 4/3 to the power of n. So that follows from the rule that a to the power of x times b to the power of x is equals to ab, all this to the power of x. And observe, even before we go to the next step, is that our r is 4/3, which is greater than 1. If I look for the absolute values of r, so this one diverges. So for question number 13, determine whether the series, so change the color to green, whether the series diverges or converges. So we have sum as n starts from 2 to infinity, n divided by 3n. So the test we use here, we find that this function, we will use integral test. And the reason being we check this function is continuous from 2 onwards. This function is positive from 2 onwards. And this function is decreasing because you can check by finding the derivative f prime and let n be equals to x. So this function will be decreasing function, decreases in that interval from 2 to infinity. The check is you find the derivative of that function. And the derivative, you use quotient rule. Let's, for example, call this one f of x equals to x. We can say multiplied by 3 to the power of minus x. In that case, we use product rule. And the derivative, it's f prime of x, which is equals to, this is u, this is v, so we get u prime v, so that is 3 power minus x, plus, now the derivative of 3 power minus x, so we attach x, but the derivative of 3 power minus x, it's minus, so we can have this 3 power minus x, then derivative of the power, that's minus, then you attach ln of 3. So we have this one as 3 power minus x minus 3 power minus x, then it's multiplied by ln of 3, then multiplied by x. If I was to factor out 3 power minus x, I'll get 1 minus ln of 3 power x, all this divided by 3 to the power of x. And this function will decrease from 2 onwards. So this function decreases. So with that being said, so we will use, so I can clear this space to show that it decreases. And let's now do the integral. So be the integrating from 2 to infinity, then n, and then we have, instead of n, let's use x. So let's use x. X, 3 to the power of minus x with respect to x. And because it's improper integral, so you have to use the limit as, let me call b approaches infinity, then integral from 2 to b, x with 3 to the power of minus x dx, and use integration by parts, whereby we know integral of u v prime equals to uv minus integral of v u prime. So our u will be x, and our v prime will be 3 to the power of minus x. So that means that the integral here with the limit as b approaches infinity of 2 all the way to b of x 3 power minus x with respect to x equals to u, which is x, multiplied by v. So we are integrating 3 to the power minus x. So the integral again will be having a minus in front, 3 to the power of minus x, but we have to divide here instead of multiplying by ln of 3. Then minus integral, and then I put the limit from 2 to b. So I can put the parentheses here to show that I'm using finding the limits of all these. From 2 to b, v is what we got. So we have another minus, so we put this one plus, and then x, 3 to the power of minus x, divided by ln of 3. No, so we don't put that one, sorry. So we put vu prime. Sorry about that. So inside we have u prime, that's 1, v. So you have 3 to the power of minus x with respect to x. So that's it. So we have vu prime, and we have v. So u v prime, so we have u. So that's another mistake. So let me put it in a nice way. So we have, let me write here, u prime equals to 1, and v prime equals to 3 minus x. So v, it's minus ln of 3 multiplied by 3 to the power of minus x. Good. So we have now whatever is inside the integral here should be v u prime, so should be minus. So that's why we have a plus. So the plus is still there. 3 power minus x. Then you have ln of 3 with respect to x. And then put the parentheses because you're finding the limit. So you have minus x times 3 to the power of minus x divided by ln of 3 plus the integral. So we should be having ln of 3 as a constant, should be have 3 minus, so we have minus 3 power minus x over ln of 3 and then the limits from minus limits from 2 to b. So the first one, so we have a limit. I can remove this equal sign here, and we have limit as b becomes big of all this from 2 to infinity. So this will become limit as b tends to infinity. So you have minus x. I can factor out 1 over ln of 3. So then this one will be to the 3x. And then another minus here, 1 with a 3x. And what we observe is that as b grows, we have 2 to infinity. So we substitute if I factor out minus also, I'll be having minus 1 ln of 3, and then limit as b grows, and then substitute the limits, infinity. So the first part, which is now x over 3x, over 3 power x plus 1 over 3 to the power of x. That's when b approaches infinity. And 2 to infinity. So the first part, when it approaches infinity, we go to 0. So we'll be having the solution here with as minus 1 over ln of 3, with the first part being 0. So 0 minus, then when x becomes 2, so I can put another parenthesis, I put 2 over 3 to the power of 2 plus 1 over 3 to the power of 2. And because of the minus, I will get it positive, and I'll have a number 2 over 3 squared plus 1 over 3 squared. That's just 3 over 3 squared. So I'll be having 3 ln of 3 over 9, which is just ln of 3 divided by 3. And that's a number. That means that that function converges. So for number 2, we have the sum as n starts from 3 onwards to infinity. So again, we will use sum as n starts from 3 to infinity. 1 over n, the root of ln of n. So we check that the term of an, in this case, again, we use the integral test. So we can write in terms of x, then this is ln of x to the power of a half because of the square root. We find that this function is continuous on the interval given, 3 onwards. This function, so it's positive in the domain given, and this function is decreasing just by finding the derivative. That's f prime of x. If this one is f of x, not an, sorry, remove an, f of x. So this one is decreasing, and you can check that one using quotient rule. You find that you have a minus sign when you do the quotient rule of that function, because the numerator is 1, so its derivative is 0. And once you find that 0, in the quotient rule, you have a minus the other part. So that one is decreasing function. So what you do now, you use the integral test. Integral, and then you use the word limit because it's improper. As b approaches infinity from 3 to b now, then you have 1 over x, then ln of x in the root with respect to x. And this we use u substitution because you have a derivative of a function and the original function inside it. So we usually choose u to be the function in the root sign, ln of x. So that will imply that we change the variables, and our du will be equals to 1 over x with respect to x. So which become limit as b approaches infinity of the integral. Now, these 3 will change using this change of variable. So on the limit down, where you have x, you put 3, so you have ln of 3. And here you have ln of b. And then dx over x, it's this one. Because we have dx over x, whatever I'm putting in the ellipse, that's my du. So I'm having du, and in the root, I'll have u. So integrating that, so we have limit as b grows integral from ln of 3 to ln of b, and you have u to the power of minus a half with respect to u. So when you integrate, you have limit as b approaches infinity, u to the power of a half, that's square root of u, divided by a half. So I can put the 2 here. And then ln of 3 and ln of b. So this will become twice, and then what is inside now become limit as b approaches infinity, square root of ln of b minus square root of ln of 3. And we observe that the first part, as b approaches infinity, the root of ln of infinity will be undefined, or it does not exist. So this limit does not exist, or is infinity, so it diverges. Let's go to question number 3. We have the sum as n starts from 0 to infinity. So we can have, now this one we will use, let's first of all write it in this manner. So we have 4n, 4 to the power of n, sorry. And then the denominator is 5 to the power of n. If you split, we have another 5 to the power of 1. So if we factor out 1 over 5, we have 1 over 5 sum, because that one 1 over 5 does not depend with n. N equals to 0 to infinity, 4 over n, and 5 over n, that's 4 over 5 to the power of n. So what we see here, 1 over 5, the sum, if n starts from 1, 0 plus 1, so n starts from 1 to infinity, then this one will become 4 over 5 to the power of n minus 1. And we can find this, it's in the form of the sum n starts from 1 to infinity, a, r, n minus 1. And the sum is always given as a over 1 minus r. So 1 over 5 is multiplied everywhere. So multiply by 1 over 5, multiply by 1 over 5. And we find that a is 1 and r is 4 over 5. So that means answer, the sum equals to 1 over 5 multiplied by a is 1, r is 1 over 5. So that's 1 minus 1 over 5. So this one becomes 1 over 5 multiplied by 1 over 5. That is 1 over 4 over 5, which will give you 1 over 5 times 5 over 4. And that is 1 over 4. So this one, the fact that r was less than 1, that's the part here. The fact that absolute value of r is less than 1, that means that the function converges. That's the point that we know that the function converges. And the sum is 1 over 4. Finally, the second to the last, we have the sum as n starts from 1 to infinity, 2 over n cubed plus n plus 1. So this, we can use the check on comparison. So we have, let's start off all by writing that we know that 1 over n to the power of p, this sum as n starts from 1 to infinity is equals to, I mean, write this clause. We say converges if p is greater than 1 and diverges elsewhere. Diverges otherwise or elsewhere. Here, when p is between 1 and that one, also diverges to infinity if p is strictly less than 0. So let's start by taking the term 1 over n cubed, the one that I want to compare with. And I'll use this here. It helps me less than or equal to, greater than or equal to. If I put another 1 over n cubed, I'm saying that they are equal. If I multiply, so this side, if I multiply by 2, that side, so that means that now I'll no longer be saying is equal. So I'll remove the equal one. And then I'll ask myself, is it less than or equal to? And because I multiplied in the numerator, that means that now the left-hand side, it's smaller. So we remove this one. But now what is happening here is now if I add n, this one will change and I'll have that this one becomes greater than. So 1 over n cubed is bigger than because I'm now increasing the denominator with a plus n and also add plus 1. So that means that 1 over n cubed is greater than 2 over a very, these numbers are divided. So this number becomes smaller and smaller. So what we know about the sum here, as n starts from 1 to infinity, is that this one converges just from the, because in this case, p equals to 3. P equals to 3. So this one converges. Now, if the one which is converging is bigger, then that automatically means that the ones which are smaller than that, they have to converge. Converges. Finally, we're only checking whether it converges or diverges. So 20, and then sum as n starts from 2 to infinity. So we can use, in this case, again, integral test as we did in number 2 or 3. Yeah, I think number 2. So we use the integral test. And we know that this function is continuous, it's positive, and it's decreasing. We can check. So then we call this function f of x equals to 20 divided by x, ln of x to the power of 5. And then we integrate because it's decreasing, continuous, and positive. So from 2 to b, and then it's improper. So limit as b approaches infinity. So we have 20 divided by x, ln of x to the power of 5 with respect to x. So this is just 20. Then limit as b approaches infinity of the integral from 2 to b, 1 divided by x, ln of x with respect to the power of 5 with respect to x. So again, we use u sub. So we have 20. So let's call u whatever is in the parentheses. So u equals to ln of x. That means that du equals to 1 over x with respect to x. That means we have 20 in limit. So let me write the word limit as b approaches infinity. This integral, so u will change, x will change. So u equals to ln of 2 and u equals to ln of b here. And then dx, this part I'm putting here over x, it's my du, so du, and then divided by u to the power of 5. So we integrate, so we have 20 limit as b grows to infinity, and then the integral there, this is the same as u to the power of minus 5 with respect to u. You get u to the power of minus 4 divided by minus 4. So I can factor out minus 4. And then I'm finding from ln of 2 to ln of b. This is minus 5 outside of the limit. Limit as b approaches infinity, 1 over u to the power of 4. Ln of 2 and ln of b. Ln of b. So this becomes minus 5 ln of limit as b approaches infinity, 1 over ln of b to the power of 4 minus 1 over ln of 2 to the power of 4. So the first part, this one, as b grows to infinity, this one will go to 0. So I have a 0 minus 1 over ln of 2 to the power of 4. And then outside of the parenthesis, we have minus 5. So we have minus, we cancel with each other, and we have a number, which is 5 over ln of 2 to the power of 4. And this one, that means that this function converges. So that's the end of the review part 2. So all the best in your exam.